Section 10.2, Parabolas. The objective of this section, to write the equation of a parabola and to graph parabolas. Lesson vocabulary, focus of a parabola, directrix, and focal length. An essential understanding, each point of a parabola is equidistant from a point called the focus and a line called the directrix. From Chapter 4, you know that a parabola is the graph of a quadratic equation. In this lesson, you will consider both vertical and horizontal parabolas. You learned that every parabola has a vertex and an axis of symmetry. A parabola also has other characteristics. Take note of the information at the right. This was a peek from Chapter 4 to remind you of the concepts of vertex and axis of symmetry. Take a moment to review and take note of this key concept. Note we have the focus labeled, the focus being that point inside the parabola, the focal length being the distance from the vertex of the parabola to its focus, the directrix, the blue line, a vertical line in this case, on the opposite side of the parabola from its focus, and definition. I'm thinking that's a typo. Perhaps that should be replaced with parabola, but I'll take the liberty to fix that for the folks at the textbook manufacturing company. There we go. That's much better. You can find the equation of a vertical parabola with a vertex at the origin by using the geometric definition. If you denote the focus by 0, c, the directrix is the line with the equation y equals -c. Then the equation of the parabola is y equals 1 over 4c times x squared. Take a moment to examine this graph. You may want to reread the passage at the top and make sure it makes good sense to you before moving on. Note that the equation has the expected quadratic form y equals ax squared for a vertical parabola with a vertex at the origin, 0, 0. The coefficient a equals 1 over 4c, determines both the focus, the point 0, c, and the directrix, y equals -c. This is the key to shifting between the algebraic and geometric representations of a parabola. Example problem 1. Parabolas with equation y equals ax squared. Part A. What is an equation of the parabola with vertex at the origin and focus 0, 2? Well, note we have the parabola graphed at the right, and notice also the focus is directly above the vertex. This is a vertical parabola with its vertex at the origin. The focus of the parabola, given to us above, is the point 0, 2, which tells us that c equals 2 in this case. Recall the general form for an equation of a parabola using its geometric definition. Y equals 1 over 4c times x squared. We know that c in this case is 2, so we can rewrite that equation as y equals 1 over 4c, c is 2, so that's 1 over 8 x squared. And we're done. Before we move on to part B, let's check out the plan box on the right-hand side. It says, how can you tell if this is a vertical or a horizontal parabola? Well, one thing we know about parabolas, the focus and the vertex lie on the axis of symmetry. In this case, the focus and the vertex were vertical from one another, meaning that we have a vertical axis of symmetry and therefore a vertical parabola. And part B. What are the focus and directrix of the parabola with the equation y equals -1/12 x squared? So here we're kind of working in the opposite direction from part A. We're given the equation. We also have a nice graph below. We're given the equation and asked to find both the focus and the directrix. So we'll use what we know about the equation y equals 1 over 4c times x squared will equal, well, in this case, will equal y equals negative 1/12 x squared. Notice how the x squareds are in common? Perhaps I should take the time here. Let's set these two things equal to one another. Negative 1/12, negative 1/12 equals 1 over 4c. Take a moment to make sure you understand where that came from and how I can write that these two things are equivalent. Note one of these values is negative, the other is positive, which means our c value, our only variable, must be negative. So c equals negative of, well, since our numerators match, we can really ignore those. 12 equals 4c, or negative 12 equals 4c. c must equal negative 3. So using c equals negative 3, we can state that the focus of our parabola is the point 0, negative 3, and that the directrix is the line y equals positive 3. Let's check out the think box on this one. What does the sign of A tell you about the graph? Well, since A is negative, we know the parabola opens downward. Were A positive, the parabola would open upward. And a chance to show that you have got it. Part A. What is an equation of the parabola with vertex 0, 0 and focus 0, negative 1.5? Part B. What are the vertex, focus, and directrix of the parabola with the equation y equals x squared over 4? And part C, a reasoning question. How does the distance from the focus to the vertex affect the shape of a parabola?